In this experiment, we will be finding out the highest common factor or HCF of two numbers using the Euclid's division lemma. The objective is to find the HCF, and for that you should know what is Euclid's division lemma and how this concept can be applied to find the highest common factor of two numbers or even more than two numbers. So let's see the concept in hand. Suppose we need to find the highest common factor of two numbers like 28 and 12. Using Euclid's division lemma, we can do that. Obviously, the method of factorization works, but that's not what we will do in the experimental setup. We will be dividing 28, the larger number, by the smaller number 12 and finding the quotient. 12 two times is 24, right? And therefore, you will get a remainder of 4. So the Euclid division lemma states that the dividend, that is 28, is equal to the divisor 12 times the quotient 2 plus the remainder 4. But you can see that the remainder here is non-zero. It is not 0 yet. So we need to perform one more step. In the second step, the divisor 12 now becomes the dividend. So we will write it like this, and the remainder, which was 4, now becomes the new divisor. So let's perform the division again. 4 3 times is 12, and you get a remainder 0 now, and that's what we wanted. Let's write the Euclid division lemma for the second step. The dividend was 12, the divisor was 4, the quotient was 3, and the remainder was 0. So when you get the remainder as 0, the last divisor becomes the highest common factor of the two numbers, that is the dividend, the original dividend 28 and the original divisor 12. So the highest common factor of 28 and 12 will be your last divisor, which is 4. Now this concept of finding the highest common factor can be used to verify and to find the HCF of two numbers experimentally. So we'll be doing that. Let's see what are the materials which are required to perform this activity. We require a graph sheet of paper on which we will be pasting colored paper sheets. The colored papers, you require at least 4 to 5 colored papers, and then a scissor to cut the shapes, various shapes which are required, glue to paste the required sheets on the graph paper. Now all these material will be used, and the experimental verification of this will be possible. So let's see how you can verify this experimentally now.
So as you can see in this experiment, we have cut some paper strips. This is of length 10 centimeter, this is 6 centimeter, this is 4 centimeter, and this is 2 centimeter. We require many strips like this because we are trying to find the HCF of 10 and 6, which involves use of multiple steps. So in the first step, we'll be taking up the 10 centimeter strip and we will be putting it here. You can see on the graph sheet exactly 10 centimeter length. So if we place it like this 10 centimeter denotes the dividend, and the next one is the 6 centimeter, which is the divisor. So we'll place it like this here, and you can see the 4 centimeter is left out here. This denotes the remainder. In the next step, the remainder 4 centimeter becomes the new divisor. So we'll place it like this, and the 6 centimeter, which was the divisor, becomes the dividend. And you can see the new remainder is 2 here. So the 2 becomes the new divisor, and what was the divisor here? It was 4, right? So that 4 becomes the new dividend. You can carry on pasting strips like this. You can see here we have the remainder 2 now. So 2 becomes the new divisor and the divisor here was 2. So that becomes the dividend. Now there is no remainder, that means remainder is 0, and therefore the last divisor, which is 2 in this case, becomes the HCF of 10 and 6. You have to paste all these paper strips like this on the graph sheet to complete the activity.